So what I've prepared here is a couple of thoughts on where we are in AI. So I work for a firm called Andreessen Horowitz. I'm here giving this talk in completely in my private capacity, just to keep the compliance folks happy. But I just want to give you an overview of what I'm seeing right now in the space and where we're heading. And so when it comes to AI, I think the overarching hypothesis is that the current AI revolution, or whatever you want to call it, is sort of a super cycle, like one of these very large tech cycles we have every 2 decades or so. The dot-com was probably the last really large one. We had like smaller ones around cloud and mobile since then, and blockchain. And so I think to look at this, the first thing I think it's important to understand what happened, right? And I think what triggered this is really a combination of two things. The first is this idea of generative AI. So classically, if I have AI, it's very, very good in detecting and recommending and classifying things. Now I suddenly have AI that can directly generate an artifact. So for example, I can train a model myself, and then for the cost of roughly 1/10,000th of a dollar, I can create the suspiciously handsome Captain America at the bottom left here. If we roughly model the cost of renting a costume of Captain America as $10, that's a factor of 100,000 cheaper than the closest alternative. Right? Whenever we reduce cost by 5 orders of magnitude, usually interesting things happen. The second, even more important thing that happened is this notion of foundation models. So classically, if I wanted to do any form of ML, I had to hire a couple of overpaid Stanford PhDs from Gates over there. They would take a training data set that would train a specific model, and then I had a model that could solve one problem particularly well. Foundation models are very different. Today, most foundation models are promptable, meaning anybody who can express a query in English can take these models and make them do a very, very broad range of tasks, right? And that's a big shift. So in essence, the result of this is we found this new construct, like a model, which can solve certain computer science problems that previously we couldn't solve in a very, very inefficient way. Right? Anything we can solve with a closed form algorithm, like math or so, we can solve much, much faster with like an algorithmic implementation. But if you don't have an algorithm, then this is a very good way of doing it. So if you look back in history, the last couple of times when we build a new building block that had major consequences, right? We today build systems with typically on top of compute, of networking, and storage. And in the future, we'll probably build them compute, network, storage, and models, or whatever this thing will be called, right? The first time we introduced one of those blocks was the CPU, right? That triggered the PC revolution. The cost of compute, if you look at the early computers, went down by about a factor of 25,000, right? Between the last bespoke computer systems and the first mass market mass manufactured CPUs like an Intel 404. Second time this happened was the internet. Sending a letter across the country costs you $1. Sending the same amount of information via the internet with the earliest pricing I could find is like a tiny fraction of a cent, so about a factor of 100,000 reduction in cost. And now we're doing it with generating Captain America photos or writing speeches or analyzing text or similar tasks. If you look back, right, in the CPU revolution, they created Intel as the hardware leader, and then Microsoft was the software layer on top, became much, much more valuable. In networks, Cisco was the early hardware leader, back then the most valuable company on the planet for a while. And then, Google and Facebook and Amazon, all the others figured out how to build services on top. If you know what the equivalents are in this revolution, please let me know, because as we see, we're obviously trying to invest in them. But it looks like with NVIDIA, we sort of have the Cisco equivalent, right? The early hardware leader, which currently is, depending on the day, the most valuable company on the planet. But I think the more important thing to think about here is, though, today, if you write software, what's the chance of it using compute, network, and storage? And for any large application, that's a stupid question, right? All of it, all software does. We don't know how to write software without those abstractions anymore. So in the future, the same will be true with AI. You build an application, it may have a little embedded model somewhere in a Python package that you pull in, or you talk to a frontier model in the cloud. But basically, we think of AI as a ubiquitous component that's everywhere. So how does the AI ecosystem or the AI stack look like? And if you would have asked me like 18 months ago, we probably would have thought about it roughly this way, right? So the product was still the model, right? I used ChatGPT, with basically a very thin shim on top of the model underneath, or like a Midjourney, which is sort of the same idea. The applications are thin wrappers. This is sort of a little similar to how other industries started out. Like if you think about databases, in the early days, you used the Oracle client to talk to the Oracle database, right? This is what happened. Today, this is looking very, very different, right? And so here's, I think, our best version, not necessarily a good version, but our best version of how we think about the stack. We still have the models at the bottom. We have some reasoning or inference time compute on top for language models. Then we have like a rich layer of workflow that's emerging that's busy combining multiple models. And then we have some more interactive applications like Copilot models and some more agentic applications that work more independently. And this is moving a lot, but it sort of mirrors of what we see in the past, right? Like today, if I use a database, I don't use the database directly anymore. I use Salesforce that has many, many layers of logic on top of the database underneath. So let's talk a little bit about what's happening in language models. So this is a snapshot a couple of days old of the top language models on the planet right now, including Anthropic. And if you look at the top models here, these are all reasoning models like O3, DeepSeek R1, Sonnet Thinking, O1 Mini. So these reasoning models are pretty interesting models in that they work a little bit different from classic models. And let me try to set up what makes them different and why this is exciting. So classically, what's driven a lot of AI development are scaling laws, which basically say, look, if you increase the model size, increase the amount of compute you can throw at it, increase the amount of data you train it on, then you can get a lower loss function, which basically means you get a higher quality model to solve certain problems. Now, the challenge with that is that training data, all the training data we have today is pretty much the internet. Right? There's nothing that has a similar size as what's available on the internet in terms of data repositories. The internet is relatively easy to obtain. Everybody's using the internet. So once you have, using the entire internet, you're sort of out of human-generated data to train models. And that's what we saw a little bit in the evolution of model test scores. So here we're plotting, or actually Maxime is plotting, MMLU scores versus time. And if you look at, GPT-4 came out in, April 23 or something like that. And, this goes to July, but we didn't make much progress after that. We saw flattening off, right? Everybody's using roughly the same model structure, generative transformer, on roughly the same data, and getting roughly the same result, right? And there's still incremental improvements, and, arguably this is a score that goes only to 100%, so we're driving the metric into saturation, but we saw a sort of a peaking out of capabilities. But then basically this inference time compute came along where basically models, instead of just generating an answer directly, were trained to think through problems step by step and do a lot of analysis and then at the end present a final answer based on everything that they thought through, right? Now this looks a little bit like this. So on the left side we have O4 Mini, asked a question about Hohmann transfers, and it gives me a direct one-shot answer of what the reply is. And here we have a distilled version of DeepSeek R1. So this is a very small model. And basically, it doesn't know the answer, but what it does is it starts arguing and thinking and trying out things and trying to derive this thing by itself. In this case, actually getting to the right result. And here's an example from the DeepSeek paper of how these models work, right? So here it's thinking through something, and at some point it says, wait, that's an aha moment I can flag here. So actually, in its thinking trace, it realized there's something interesting going on. And then what they did for DeepSeek is they basically took these traces and then used them for fine-tuning the model in the end. So basically, you can use the ability of the model to reason through things and think through things to then further train the model, right? And I think they even updated the evaluation function for reinforcement learning with this. So we're starting to see a little bit how models with experimentation can get better, right? And that's pretty exciting because if sort of there was this sort of topping off of model performance because we're running out of pre-training data. If we only train on human-generated data, we now sort of have a second curve here, where model performance increases again. And I think at least I personally have no idea where this curve will top out, right? So we have a new thing that we can sink in lots of compute in order to get better, and without a clear top that we can get to. So one of the big topics at the moment is agents, and my big problems with agents is I don't actually know what they are. I mean, the number of definitions is staggering. It's everything from fancy rebranded workflow to AGI, I think. It usually has a notion of having some internal state over longer periods of time and working with less user interaction. But it's at this point has become a bit of a marketing term. It's also sometimes used to justify different charging models. So, because this is an agent, you should pay for it like you would pay for a human. So, in terms of tens of thousands of dollars a year, which sounds great. in practice, one of the hardest hit industries from LLMs at the moment are translators. If you had a translation business, you're not looking very good these days. And do I now suddenly pay GPT-4 the same I would pay a translator previously? No, I don't, right? I paid a tiny fraction of a cent for translation. So I think it doesn't quite hold yet. One thing that the truly agentic agents that try to do longer time period things, with substantial internal state state, they usually don't work, at least in my experience. We haven't seen many companies that actually have sort of agentic systems with persistent long time state that are stable. They're fundamentally autoregressive systems that feed their state back into themselves, and they eventually veer off. And unless you have some way to correct that, which you do in like for software development and some other areas, but for most areas you don't have that correction function, and then it's very hard to keep them stable. So another very interesting thing about LLMs is that they're getting cheaper really, really quickly. So what I'm plotting here is the cost of a model of equal quality over time, right? So I say GPT-3 had, when it came out, an MLU score of 42. So I'm always looking for the cheapest model I can find at any given point in time that has at least 42 mmLU. And if you plot this, this is logarithmic on the y-axis here. So if you plot this is about a 10x reduction in cost year over year, right? Which is fantastic. I mean, Moore's law is halving every 18 months, right? This is much, much faster in terms of decline. We have less data for the better models, but it's like it seems to be going roughly the same direction. This slide is a little bit older. I believe at this point, the cheapest model that you can find that has the quality of GPT-3 costs you 1.6 cents per million tokens, right? So running the entire Harry Potter series through an LLM is about 15 cents, right? It's absolutely ridiculous how cheap that has gotten. These models also run really nicely on your laptop or other edge devices. So here I'm running Llama 3.23b on my laptop. It does a reasonable job, 53 tokens per second, right? And the models are more or less free if you use them. So this is great if you want to start a company, because it means that if today your business model has negative gross margins and the metrics are absolutely terrible, that's okay. Just wait, tomorrow you'll be fine, right? You can literally make it up in volume here, which is, that doesn't happen very often in tech. All right, so what can you do with these models? Some of the biggest applications right now is software development. I'm talking to a lot of large enterprises how to use these models. So what I'm hearing from them is that they're seeing about while somebody is coding, if they usually use Copilot, they're seeing about a 25% productivity increase for their developers, right? They're tracking this in a fairly sophisticated way. They code only half of the time, the rest is meetings, so effectively it's maybe a 10 to 15% productivity gain. But if you have a $100,000 a year employee, for a few $100 you can make them 10% more productive. That's still an incredible business case. So this is taking off very quickly. There's a company called Cursor that you may have heard of, which by some metrics may have had the fastest growth from 1 million ARR to 100 million ARR they grew in less than a year, in the history of startups. Right? So this is incredibly fast growth. I think if you think about this a different way, right? So we have about 30 million developers in the world. If each of them, generates $100,000 in value, that's $3 trillion total. So making them 10% more productive, that adds about $300 billion to the world GDP. So these are some absolutely crazy numbers, right? So currently Anthropic, I think with Sonnet 3.7 has by far the best coding model. And if they make their model 10% better, that has a measurable impact on the world economy. Right? So it's a very, very strange moment in time. So a lot of them are used just in your IDE. There's another class of models, another class of applications that basically plugs into your source code repos. So where you can basically just have another person discussing your pull requests, and they can comment on pull requests, so ask the app to implement them. And they start working. So, vibe coding, I have implemented features on my iPhone. Right? And these are simple features, right? It's typically more for reviewing things or fixing a simple bug, but you can sometimes actually implement features, just by writing a little instruction of what you want in a GitHub repo, and everything else happens automatically. It's magical if it works. All right, good. So that was text models. Let me talk about image models for a second. So image models are they're a ton of fun. They're smaller, they're faster. So what I'm doing here is on the left side, I'm doodling. This is done with Krita, an open source drawing software that's tied to a Comfy UI that's running in the cloud. So on the left side, I'm doodling. I give it a prompt at the top, letters spelling A16Z above a beautiful landscape, waterfall. And as I'm drawing, it basically tries to interpret what I'm drawing and turn that into a picture, right? This is recorded in real time. Right? So I think this is how the next generation of kindergartners will probably learn drawing. Right? You just sketch, and the computer then turns that into an image. I'm getting pretty good here. Huh? So this is done. Sorry. This is an older recording. I want to say it was still Stable Diffusion, 1.5 probably. But you can run any of them. Anything that runs in Comfy UI, which is about the same as anything, just run that in the cloud on a cheap instance, and then take Krita locally and wire to it. It's kind of the easiest solution. A ton of fun with kids if you've ever done it. So this is done with a vanilla model, right? As just from one of the providers. The fun thing is you can train models on yourself, right? And then you can basically generate photos of yourself. Or you can train photos on a particular style. Like, so for example, this is from an online sort of community hub called Civet, where people post fine-tunes of models for particular styles. So they, at this point, I think they have over 1 million different fine-tunes, or LoRa's of these models. And so here is a watercolor model that's very good in generating watercolors. And the nice thing about LoRa's is they're delta, so you can stack them. So here is the watercolor LoRa with my LoRa on top of each other, and then you can generate yourself in watercolor. Or for something more interesting, take the Norman Tapestry style, and then I have myself in Norman Tapestry style. And the level of specificity for these LoRa's is incredible. So here's maybe my favorite. This is the golden ivory kitchen appliance fine-tune. I have no idea who came up with this, who spent the time to fine-tune a model for that. But as an artist, have an incredible amount of creativity at your fingertips here. You can do things like age, that's young me, medium me, and old me, meeting up here. Or, you can actually parameterize this. So by basically adding, by fine-tuning a LoRa on a particular aspect and then adding more or less to it, you can basically get a slider where you can continuously dial up an aspect. So you can, age or surprise, or smile. You can just, adjust them in your picture in whatever way you want. You can not only do properties of the image that are true for the entire image, you can also do this in terms of specific geometry. So what I have here is open pose data. So this is how people are standing, right? How joints are oriented. Then I can say, take this data, and render me some white robots on a blue background, or some humans in front of a sunset, or some shiny robots in front of a futuristic city. And so I can basically now exactly drive the geometry of the particular photo. We can do this with hand gestures. We can do this with facial expression. So there's a ton of creativity. I talked to a marketing agency, and they say when they do a celebrity photo shoot these days, they invite the celebrity in, take a couple of photos, train a model, rig a scene in Blender, extract depth map, extract pose information, do a pre-rendering, and that's what they actually use for their press shoots, right? Which is a huge change in workflow versus how it used to be. This is how these things look like. This is from Comfy, how you basically wire the different pieces together. Not quite your typical Photoshop UI anymore, right? It's a big step from what you used to have. All right, let's talk about video. And let me play this and then tell you about it.
Ladies and gentlemen, gather round, for you're about to hear a tale that combines the marvels of modern technology and a dollop of delightful absurdity.
All right, I'll spare you the rest, but this is my 13-year-old daughter, and she basically wrote a speech with GPT-4, trained a speech model on her voice with 11 laps, right? Then used Replicate to generate a cartoon representation of herself, did HeyGen for the lip sync. And the sync is a little bit off here, but that's due to the audio. So if you can do this today with a very high quality, whereas an exact match. Today, you can get all of this turnkey. There's companies like HeyGen. Like HeyGen, for example, can do all of this today. It's really, the point is more like for video, typically you have multiple models that you combine in these workflows and then use through an app, right? And that's getting more and more common. Here's another example for video. So one of the challenges for video is that text to video doesn't work particularly well yet. So what you typically do is that you generate keyframes, and then basically, once you're happy with them, then you generate the video in between, right? So in this case, I generated keyframes about me conjuring up a GPU. That's like everybody's dream in the AI industry right now, right? And it works great, right? So if you have the beginning and end with a couple of tries, you'll get a good video in between. Here's another interesting application, so replacing people. This is a Wiggle, which is an iPhone app you can download. The first couple of pictures are free. This is like little Yachty walking out at a concert, and at the top, somebody just plugged in the Joker. Right? So you can try this out, a couple of photos, and this will work. Here's another example. This is one of our investors. She took an old home video of herself and just turned herself into an anime personality, right? This is a simple open source model, right? This is something which we can do today very, very reliably and very easily. So one more modality here, which is music. So music models haven't gotten incredibly good. So good that currently tons of lawsuits flying around because some people are trying to stop them. Other people are very excited about them. If you followed the Drake versus Kendrick Lamar battles from last year, there were some samples in these songs that were actually AI generated, like BBL Drizzy, if anybody knows that. So to show you a quick example here, so here somebody took the summary of Dune, the movie, which you've probably seen, asked a model to generate the show tunes musical version on Broadway of Dune. So without much further ado, let me play this.
The greatest leader we've ever seen. They say that he's the listen guy. Eyes bright blue and hair jet black. You should see him ride on a sandworm's back. Lead us to victory, Yusuf Muad'Dib. Oh, we love you all.
All right, perfect. So, if there's any reason why AI should be banned, I think it's this music here. This is all just generated by one neural network, right? You feed in the text and you feed in the topic, and out comes the music. It's absolutely amazing what you can do with this technology. So this is roughly how we think about the stack that comes out, right? So you have the compute hardware at the bottom. NVIDIA is dominating. Google is the number 2. Everybody else is struggling. We have cloud platforms, all the old ones, Amazon, Azure, Google, and then a couple of new ones like CoreWeave, Nebius, and others. They're specializing on AI. And then basically we have models with some additional inference time compute sort of for the language models, which is sort of seems to be emerging as a separate component. Then workflows, where basically people with an infrastructure layer that combines multiple of these models and some pre and post processing and turns that into an easy-to-consume API. And then on top, we have co-pilots or agents that use these models plus workflow in applications. And by and large, it seems to follow roughly the same metrics as classical software. So it's it looks like a very healthy ecosystem with a mix of open source and closed source, and many players in the stack. And with that, I think we have a couple of minutes left for questions. Yeah. If there are questions.
I'll ask a question. So I'm curious what you think. So I think Mark Zuckerberg was saying that in 5 years, Facebook is not going to need any developers or so. So I'm curious what you think about the state of these models, and is that really true?
Look, currently predicting 5 years out is kind of speculative, right? If predicting 12 months out is sometimes a little bit speculative. My current impression is, at least with the models, with anything I've seen today, I think it's not true, right? I think because what you can do by instructing a model is amazing, but you need a fair amount of understanding of how coding works in order to instruct it well, right? I mean, we're seeing a big difference in the productivity gains between the senior developer and the junior developer just because the senior developer knows what they want, right? they can be very, I want this kind of structure, this kind of function, this kind of I/O, and then you get much better results. The second problem is occasionally these models get wrapped around an axle, right? They somehow confuse something. Let's say they had half as much training data about an old API version, a new API version, and somehow that the differentiation didn't make it, and so they mixed the two. In those cases, you have to at least be able to diagnose what happened, and doing that requires a good amount of software understanding. So I think my money right now is, and again, right, it's hard to predict the future. My money right now is that we'll see a huge step up in developer productivity. Right? Does it mean less developers? Maybe. Does it mean more developers? Also maybe, because Jevons paradox tells us, right, that sometimes if something gets cheaper, right, you may actually increase overall spend on that particular resource. I think we really don't know yet.
Okay, I had over here.
Oh, there.
I had a question, actually, a good counterpoint to Dan's here, which is because he was focused on technical and useful, call it knowledge work. I'd actually like to ask you a question about on the creator economy side. Because Kevin Kelly had that great 1,000 fans or 100 fans, whatever the number was, way predating Patreon and everything. remember back then, and even with Patreon, everyone was like, yeah, but everybody can't be a creator, da-da-da. How optimistic are you that like this might be an answer, to the AI apocalypse and the automation apocalypse around human work? Does this actually offer a thing where humans are able to, at large become kind of creators and interact? And, I'm just curious how optimistic you are on the social movement side.
Yeah, it definitely changes things a lot. I mean, look, I don't think we fully understand yet how, but I mean, like, if I go back in time, right? Let's assume this was the Middle Ages, and you were a monk writing books, and I would have come to you and like, hey, can you imagine the #1 best-selling author wrote a 10 million word, 7-volume, set of novels on a wizard in a wizarding school. That's the best-selling author in the world. You'd be like, well, this is, and she did it all by herself, right? You'd be like, this is completely crazy. I mean, look, you need people who make the parchment for you. You need people who mix the inks for you, right? You have people who illustrate the first letters in the books. You can only do this at a small scale, right? This will never happen, right? I mean, it's like you cannot democratize it that way, right? And here we are, right? So I think it's a little bit the same thing, right? I mean, the first question is, how far are we away from, J.K. Rowling being able to create the Harry Potter movies herself? We're still far away from that, right? But it's starting to be conceivable, right? Could she do the art herself? Probably at this point, right? So if she's into prompting. So I think it'll be a shift away from requiring a lot of production to creativity becoming more important, right? We had an AI artist retreat recently where somebody said, what was it? Art is creating out of distribution samples, right? Like models, they learn a distribution, right? And if you create a point that's outside the distribution, they couldn't get by interpolating any other two points. That's real art, right? That brings the field forward. So I think there'll be a democratization on that side. It'll also be very disruptive, right? I mean, today, if you're in low-end illustration or you're generating marketing jingles, you may want to think about other job options, right? This is just, you won't need nearly as many people of that type anymore in the future. There's a whole other question about how will copyright look like in this regime, which I don't have wrap my head around that yet. I mean, but there's some interesting things where we're seeing that people directionally train better models in places where copyright and fair use is more liberal, right? Which makes sense, right? And so those places will probably drive copyright legislation, and so at the end of the day, where this will end up, I don't know yet. But I think there's some interesting challenges there. Yes.
So piggybacking on Robert's question about content creation, I think if you look at the media companies nowadays, now, there's a very famous company called Knight Media. They are founded by a guy who used to run sports agencies, basically agency for like sports stars, and now they signed Mr. Beast and basically all the 1 million plus YouTubers, and they are pretty far away from the content generated by AI. I'm curious about how you think about this. There's a two end of the extreme, right? Like if you think about very much centralized on human. You can think of Mr. Beast or even sports celebrities. They are creating content, entertainment for people, general public to view. And the other end is potentially AI related. How do you think the landscape would shape with more advancement of the AI technology?
I think absolutely everybody will use AI. Look, I think to your example, Mr. Beast is currently available with him speaking, I want to say 23 languages or something like that. I don't know the exact number, right? Clearly, that's not him speaking. And so they're making massive use of it. Like on sports, we had like chatbots where I could chat with certain players from certain teams online. Those were AI chatbots, right? So I think they're all leveraging it heavily, right? I mean, I think it brings the question down to like what is the creative part? What is the how much, say, of a personality do you want to pour into AI and have AI do it versus how much do you want to retain for yourself and so on? There's lots of cool questions there, but this is ubiquitous, right? I mean, this is like, photos that don't use Photoshop. Yes, they exist. It's not the norm, right? I think the same will be in the future, photos that don't use AI. There was one, yes. I think it's the last one, is that right?
Yeah, sure, last one. Can you repeat the question? Yeah. No, I mean saying like.
So the question was, did I ask my daughter, about how she wants to live in the future with AI, I assume, right? And did I hear anything back that I'd never thought of before? I mean, she's doing a lot with AI, right? And there's constantly new things where I'm like, I would have never used it that way, right? Where I'm learning. Like, for example, when she codes, she often, will tell Cursor what code to write, right? And then she'll be like, why did you structure it this way, right? And get into dialogue with AI to have the AI explain coding to her. Right? It's like, okay, I never would have thought of that, right? I would have used it to outsource tasks, but as a teacher, right, that's sort of a new thing. Or, using it more as a sparrings partner as you think through problems. I think that's something she also did before I did it. Brainstorming. Yeah, I mean, it's just like, look, I want to solve the following problem. This is my current plan. What do you think, right? And get a critique back, right? Or, like in her case, it was more like, well, how do people do X? And, you get something back, right? But it's sort of using this as a way to engage in a dialogue, to think through a problem.
Awesome. Thank you.
Super. Well, thank you. Yeah.